Algebra, Chapter 1, Lesson 1, and we've been looking at algebraic expressions, and we talked about how to evaluate those expressions. But before we do any evaluating, I wanted to look at order of operations. It's very important in math, especially, that we all are doing the operations in the same order, because if we have one person doing one order and another person doing another order, we arrive at different answers. And very quickly we can see that in this example here. We start with the same expression. The person on the left decides to add the 3 and the 5 first, while the person on the right decides to divide 6 by 2 first. That leaves them each with different expressions. The person on the left then subtracts the 6 from the 8, while the person on the right adds the 3 and the 5. The person on the left then is left with 2 divided by 2, and the person on the right is left with 8 minus 3. And so you can see we get two very different results, even though we both began with the same thing. And this is what happens when we do different order of operations. Now, order of operations, where did they come from? Now, you can do a little research on that if you like. And really, there's no specific point at time where someone said, this is the way we're going to do it. It was kind of developed over time. But over time, we came to prefer a very specific order. And as mathematicians, we all agree to do the same order so that we can share our work with each other. If I take this problem and do it this way and share it with someone in another country who does their work this way, well, we arrive at two different answers. We can't share our work. And that obviously becomes very important. We're talking about a global economy and sharing technology and those types of things. So we decided many years ago that we're going to do our operations in the same order, and everybody's going to do it that way. That way, everybody's going to arrive at the same answer. So, to avoid having this problem happen, we're going to do an agreed upon order of operations, and this is what they are in a summary. We perform operations inside grouping symbols first, and I'll talk about those in a moment. We then simplify the powers, or we do the exponents. We then multiply and divide in order from left to right, and that's very important. And then we add and subtract in order from left to right. And some of you might have heard this before, put in the acronym Pemdas. You may have heard Pemdas before. Pemdas, a way of remembering that is please excuse my dear Aunt Sally. And what that means is each one of these letters represents what we need to do first, or the order that we need to do the operations. We need to work within the parentheses first, or really any grouping symbol. Once we've done that, then we can work with the exponents. After we've done the exponents, then we multiply and divide from left to right, and then add and subtract from left to right. Now, grouping symbols can include parentheses, which tend to group things together, braces, which group things together, and brackets. And there's also another grouping symbol. It's actually the fraction bar. The fraction bar is also a grouping symbol. You have the numerator, which is a group of things, and the denominator, which is a group of things. And when you're simplifying, you need to simplify the numerator and then the denominator, and then you actually do the division problem. So the fraction bar is also a grouping symbol. Now, when you have multiple grouping symbols, you're going to start on the very inside, the innermost grouping symbol, and then work your way out. Okay? So parentheses, exponents, multiply, divide, add, add, and subtract, or PEMDAS, is a good way to remember this order of operations that we talked about before. Okay? One of the most important things that we have to remember, and this is very important, we always work from left to right, just like we're reading a book. It's very, very important. It's a very common mistake to want to jump around and see, oh, well, these two numbers over here give me a nice even number. I can do those first. Oh, and then these two numbers. Oh, and then now these two numbers give me this nice even number. And you want to jump around and just do what's easy, what jumps out at you. You really have to work on avoiding this temptation, not to jump around, but you're always working from left to right. And that's why we work in step. We do left to right, we do all the grouping symbols. Left to right, do all the exponents. Left to right, multiply and divide. Left to right, add and subtract. So you actually be working from left to right multiple times to make sure that we arrive at the correct answer. We want to use parentheses to substitute before we simplify, and I'll talk about that when we actually do some examples of evaluating. We then want to look for the grouping symbols and perform any operations within the grouping symbol first. We then want to work from left to right and apply the exponents. We then want to work from left to right, multiplying and dividing in that order from left to right. And you can do both of those. School's out. You can multiply and divide working from left to right, and you can do multiplication and division at the same time. After you've done that, you go back and you then add and subtract anything that's left, again, working from left to right. And again, you may do both of those at the same time. The only thing that you cannot do is you can't multiply and divide and add and subtract at the same time. So you're going to need to go through, multiply and divide everything that you can, then go back and add and subtract everything that's left over. So then very quickly as a review, what you want to do is after you've substituted the number in for each of the letters, you want to go within each grouping symbol and simplify within the grouping symbols first. After you've done that, you want to go through from left to right and take care of all your exponents. You then want to go back and work left to right, multiplying and dividing. And then you want to go back and add and subtract. Okay, in that order, don't skip around. So let's take a look at an example where we simplify an expression. So here we're given an expression. Now as I look at it, I see a grouping symbol here and then an exponent inside, another grouping symbol and some division and multiplication and all going on. So the way we want to do this is we want to look at Pemdas, parentheses first, and we want to look at the innermost parentheses or grouping symbol first, and that's this one here. So I need to take care of this operation within this parentheses first. Okay, so as we do that, we do 13 minus 7, which gives us 6, and that's squared divided by 3. Now notice that's within a grouping symbol. So that means within this grouping symbol now, I need to go through Pemdas and take care of all of that inside of this grouping symbol. So within this grouping symbol, I look at any more parentheses. There aren't any. So then I'll go to exponents. There is an exponent here, so I need to take care of that first. So I'm going to do 6 squared, which is 36. So by taking care of that power, that takes care of the exponent. Now within this grouping symbol, I've done the parentheses and the exponents. Now I can go to my multiplying and dividing from left to right. So 36 divided by 3, I can divide that. That's 12. All right? And now I'm left with an expression that's simply multiplication. Again, we talked about parentheses next to numbers being multiplication or any kind of grouping symbol. So then we have 2 times 12, which is multiplying those grouping symbols, and that gives me 24. Now that I've done all the multiplication and division, I would look to add and subtract anything. If it's left, there's nothing left. So 24 is the simplified expression of this very somewhat complex, in comparison, algebraic expression. So remember PEMDAS, start on the inside, work your way out.